Hi, this is Paul. We're doing Leetcode must know interview questions, and today's challenge is binary tree level order traversal, rated medium. Just from the title, it sounds like it would be easy, but the challenge is given the root of a binary tree, return the level order traversal of its node values, left to right, level by level. That's just a breadth first search. Okay, well, the output is a little bit different. So instead of putting each node, instead of putting like 3, 9, 20, 15, 17, it does have, it's a list of lists. So each level is a list. Okay. Constraints, it goes from 0 to 2000, so we do have to handle the possibility of a null a null root being passed in. Other than that, this is really exactly like the last two problems. One of them was a binary tree. Well, actually, here, let me pull it up. Binary tree right side view. And the solution was just breadth first search, keep track of the number of nodes at each level, and when you get to the last node, add that node to the answer list. There was another problem, like average of levels. Same thing, breadth first search, keep track of the levels, sum the values at each level, and when you get to the last node in each level, compute the average to divide the sum by the number of nodes in that level. And well, again, this is just so generic that we can really just copy, a breadth first search. I mean, the thing on these, Leetcode questions is not to try to remember how to solve one problem. It's to learn how to recognize patterns in problems and know how to implement certain common algorithmic patterns like a breadth first search, which you implement with a queue. So I'm going to copy the solution to that problem, and we can probably use it almost as is as a solution to this problem. Okay, let's see. Now, the result is a little bit different. It's a list of lists. So let's change this. You can see up here, it's a list of lists. Whoops. List of lists is what we're returning. So we'll say list integer result equals new array list. It is possible to get a null root, so we'll leave that in. Get the, what is passed in here? It's called root. Okay, so we'll create a queue and add the root to the queue. Iterate through as long as the queue is not empty. And every time we get to a new level, we compute the level size, and in this case, we are going to have to, every time through, create a new list for the level. So let's say list integer, we'll call it list equals new array list. All right. And then a for loop through the level. dequeue the first node and add it to the list. Okay. When we get to the last node in the list, what we want to add to the result is list. So we want to wind up with a list of lists. Now the rest of it is the same. It's for a breadth first search, put the root node in the queue, dequeue it, and then put its child nodes in the queue. And continue to process the queue in that way until there aren't any more nodes left. Just every time through dequeue a node, put its children in the queue, and then return the result. And I think that's it. Let's try and run it. Compile error, list, add node. What's wrong with that? Oh, wait. What line is that? 34? Oh, not list, add node. List, add, I'm sorry, it's result. No, actually that looks, not node, node.val. Sorry, node.val. Okay. All right, so that's accepted. Submit. All right. All is well. 1 millisecond. Apparently some people were able to shave off a millisecond there. Somehow our memory usage was not great. Is that, I don't know, would I get that every time, or is that just an anomaly? Let me try it one more time. Oh, look at this one. Wait a minute. Oh, yeah, see the memory was better that time. Okay. Well, that's it. Again, breadth first search. You should know how to do a breadth first search. It's just, recognize problems that can be solved with a breadth first search, and know how to implement a breadth first search, and you'll be fine. So I hope you enjoyed the video. Feel free to like, subscribe, comment, and see you next time.